Good evening, good morning, good afternoon. I'm not sure where you are and what time you're watching this, but welcome. My name is Dr. Neville Sweijd, and I'm the director of the Access Program. It's my pleasure to welcome you if you are participating in the online version of the Habitable Planet course. This course is part of our program, Access, which is funded by the South African government, the Department of Science and Innovation, through the National Research Foundation. And really, what we aim to do with this course is to inspire you and to entrain you into a career in climate or earth system science, which is really what our program is focused on. And you come at a very important time. We are facing some very significant challenges. And really, what we need is we need people such as yourselves, young, enthusiastic, optimistic, creative, innovative young people who are going to help us find solutions to these really serious problems that we are facing. And I know that you'll have a good time in this course and you'll learn a lot. And we hope that at the end of the course, you will join our program as a Planeteer, and hopefully we will see you in person participating in several of our activities. Now, I said we're in a very serious situation. In fact, we are. We can't pretend that we're not. And what I want to show you now is what the situation is really from a broad perspective and what the real challenges are and why it is that you can play such an important role in helping us find these solutions. Because all of the information that we share is really derived from professional researchers and scientists who make discoveries, who find solutions, who understand the dynamics of our fascinating Earth system. And here we are in a situation which I'm going to show you a couple of slides from, which is really unusual. At the moment, we're in a situation where the temperatures on our planet are really unprecedented, at least in terms of human civilization. And what you're looking at here is a global average of the air temperature, the daily surface air temperature. The dotted lines are long-term averages with standard deviations over long periods of time. And the gray lines are 2021 and 2022, highlighted in the darker grays 2022, which you can see are much warmer than the average. But it's really 2023 that was quite shocking. That was last year, where we saw temperatures that have not yet been recorded on the planet. And in the red, you'll see 2024, which is even warmer than 2023, although we can see it starting to merge with the same levels of warming as we saw in 2022, relative to this long-term average. Now, this is useful and important information because it tells us that the planet is warming, as is predicted by global warming and climate change. If we break it down just a little bit, and we look at the difference in that rate of warming between the southern and the northern hemisphere, we see some important features. On the right-hand side is just the northern hemisphere, and we can see that warming. We can see the red line of 2024 tracking that of 2023. If we look on the left-hand side, we can see the southern hemisphere, and of course, our cooler season is generally in the winter time, which is in southern Africa, right here where we are, in the middle of the year. So therefore, the temperature graph is inverted. But if you look at the red line, and I want you to zoom in on this position here, and I hope you can see my mouse, you'll see that, in fact, what we are seeing is a departure from average much greater than we're seeing a departure from average in the northern hemisphere. So while the northern hemisphere is having a hot summer, we are actually having a hot winter. Now, that might seem crazy to you because if you live in South Africa and where I come from in Cape Town, we've got a very cold and wet winter. But this is an average. And of course, nothing really exists on average. It's very dynamic, and I want to discuss that next. But what's important is that it's not just warmer summers, it's also warmer winters that we're experiencing. What you're seeing here on the left-hand side is a reference to a document you could get online from the World Meteorological Organization, which kind of tells us about all the records that were broken in 2023. On the right-hand side are measures of sea surface temperature, global sea surface temperature. And again, you can see 2022 in the orange and, sorry, 2023 in the orange, 2024 in the black line, on the top black line, showing how much warmer the ocean surfaces are. And that's important because that really is a very significant driver of weather, which I'm going to come to in a moment. Now, what is important to note is that 2023 was an El Nino year, and we are now heading into a La Nina. I'll talk about that just in a moment, and you'll learn about that in this course. But why I wanted to talk about that is because I want to emphasize that climate does not happen on average. Although climate is defined as the average of long-term weather, it doesn't really, weather doesn't happen on average. We don't experience climate as an average. And what you're looking at here is an image taken, a composite image developed for the date was the 22nd of July, sorry, the 28th of July, which is just a few days before I record this message. And what I want to show you is you can see colors on that chart, and the colors represent the redder they are, the warmer relative to the long-term average, and the bluer they are, the cooler the sea surface relative to the long-term average. This illustrates two things. One, that there is high variability in how the patterns of climate are. And secondly, it also indicates that there are some areas where the ocean temperatures are cooler than average rather than just hotter. This is important for the next slide. I first want to point out that the global daily mean air surface temperature, as I pointed out earlier, is really significant. And on average, we experienced the warmest day ever recorded. Doesn't mean in the history of the planet, but certainly in the history of our civilization. The warmest day ever recorded was on the 22nd of July. And it's only 17.5 degrees. And you might think, well, that doesn't seem so warm. But of course, remember, that's an average. So you have to take the coolest and the warmest, and you develop the average from that way. But what I really want to talk about is El Nino and La Nina. And you might have heard of these. Perhaps you know what they are. These are phenomena that occur in the oceans. It's really an ocean atmosphere scenario. And what this is really a set of configurations of the climate system. There are several of these, but one of the most powerful is the ENSO, or El Nino Southern Oscillation, which occurs in the Pacific Ocean, but it affects the climate globally, and it affects Southern Africa too. And here's an example of some forecasts that scientists such as yourselves can become involved in trying to forecast what the next season is going to look like rather than very far into the future. And this is important because it affects our weather. And what is predicted here is that you'll see these red lines are showing different parts of the season. So this is January to June, August, September, September, October, September, October, November, October, November, December, and so on. And you can see as we progress into our summer, the likelihood of a La Nina is increasing. And this is another metric of that, which is more likely to be a La Nina than an El Nino. And the predictions look like this. So you're looking at a world map and you're looking at those different parts of the season. So let's concentrate on where we are now, July, August, September. You will see these are again anomalies. The yellow are warmer than average. The blue are lower than average. And you can see a tongue of water, of cooler water appearing here. And as we progress into the summer, and we get to say November, December, January, the prediction is that we're going to have a lot of cool water at the surface. Now, this is important because it affects our weather in Southern Africa. Generally speaking, when we have an El Nino, we have a much drier and warmer season. And in eastern parts of Africa, that translates into a wetter season. But when we have a La Nina, almost the opposite. We have a cooler but wetter season. Sometimes we see flooding associated with these La Ninas. And so we're predicting a La Nina for the coming season. And I'll show you this because I really want to illustrate to you how dynamic and that the climate and the Earth system is changing all the time. It's not an average, it's very dynamic. And this makes studying it very interesting and also very challenging. And there are consequences, and one of those consequences is, as you must be aware, extreme events. And this just illustrates that over the last several decades, the number of extreme events, particularly flooding events and extreme weather events, as well as droughts and other phenomena, um, have occurred at a much greater rate than they have in the past. And so, really, the expression of climate change is in changing weather and extreme events. And that's important because that's how people experience it. And so there's so much work to be done, so much to learn about our planet in order for us to understand these feedbacks and these phenomena and these interactions between the oceans, the atmosphere, and the land. And really, the idea is that you, as a scientist of the future, of the near future, should become involved in this to help understand these problems and for us to find solutions. And I hope that this is interesting to you, and I trust you will have a great time doing this course. And I'm looking forward to hearing how you experienced it and hopefully meeting you sometimes in the future. So thank you all very much for participating, and we'll see you again soon. Thanks. Bye-bye.